My name is Sean, and I'm delighted you're joining us today's ESPC community webinar. Today I'm joined by Stephen Bisser, MVP, who will present Copilot Agent Test Automation from prompt to production with confidence. We love hearing what you have to say, so remember join conversation about today's webinar and more on X. Our handle is @ESPC_community and our hashtag is #ESPC26. Tweet us, tag us, and tell us what you learned. Don't forget to check out our Learning Hub, which updates the latest blogs, ebooks, webinars, and how-to videos. You can access and view the Learning Hub by visiting our website, espc.tech, and clicking the Learning Hub tab at the top of the page. Don't forget to join us for our next webinar, A Developer's Introduction to Copilot Studio by Albert Jan Schott, MVP, taking place this evening, Tuesday, 12th of May at 4 p.m. CEST. To register, visit Microsoft Copilot Week registration page. Join us at ESPC 26 this November in Amsterdam. The newly announced program features 120 plus sessions across 9 expert-led tracks covering Microsoft 365, Copilot, AI, Power Platform, security, governance, agents, and more, including real-world insights into Microsoft experts and MVPs. Super early bird tickets are available until 26th of May. Use Copilot Week for additional savings and book using the QR code. Early bird pricing ends Friday the 15th of May. Secure your ticket to EPPC 26 today and expand your knowledge across Power Apps, Copilot Studio, Copilot, AI, Power Automate, Security, and Dynamics 365. Use code Copilot Week for additional savings and scan the QR code to book now. After the webinar, we'll have a dedicated Q&A session. Please feel free to type any questions you might have in the chat box. Question will be selected and answered at the end of the presentation. This webinar will be recorded and added to the Resource Center, where you'll be notified by email when it is available. And now I'm going to pass you over to today's presenter. Hello, Stephen. Thanks for joining us today.
Hi, everyone. Thanks, Sean. Give me a second. I'll share my screen so you guys can see actually what I'm going to show you. Here we go.
Perfect.
All right, cool. So thanks, Sean, for the intro. And hello from a rainy Graz, Austria. My name is Stefan Bisser. You might wonder why there's another name on that slide. I should be accompanied by Tommy, who is unfortunately sick, so I'll be flying solo today. But nonetheless, I'll try to make the best out of it and give you the whole intro into Copilot Studio Agent Test Automation for the next 55 minutes. So let's dive in. If we look at how software behaves, especially classical software used to be compared to math, right? But if we think of building agents these days, which is the only thing we're building at the moment, we kind of compare agents to classical software, because in my opinion, agents, large language model agents, they behave more like the weather instead of behaving like math. So we tend to require a different kind of engineering assumption when building large language model agents than we used to when building classical software, right? Because the same input we sent to an agent does not guarantee us the same output each and every time. Context changes the behavior of the agent itself and also the way it responds to a given input. And also, when an agent has a set of tools which you can execute, the output also will change dynamically. So the output exists within a given probability distribution. And nonetheless, large language models and agents, they're not random. So is the weather, because the weather is also not random. For me personally, sitting here in Graz, Austria, I cannot demand that the weather tomorrow will be 40 degrees because today it's like 5 degrees outside. So the weather is not random, large language models are not random, and therefore agents using large language models, they're not random, but they work within a given probability distribution. And so if you think of agentic systems, we can compare them or think of agentic systems as somewhat hybrid systems, right? Some parts of an agentic system, of an agent, behaves deterministically, whereas other parts, they behave probabilistically. So the deterministic components, those are the APIs you're using within your agents. Those are the authentication components, database operations, the logic you apply to certain workflows within an agent, permissions and business rules. All of those components, they are deterministic. Probabilistic components are the reasoning mechanisms applied within a large language model or within an agent. The summarization approach, the tool selection, the planning, the orchestration, natural language understanding and generation. Those are probabilistic components, and therefore we can see agentic systems or agents more as hybrid systems because they combine deterministic and probabilistic approaches. Whereas classical software engineering most often still applies to a more deterministic way of thinking about it. And therefore, when we need to treat the whole stack of engineering those agentic systems, either deterministic software or AI magic isn't the one which fits solely. It's more of a hybrid approach, basically. So you can think of your agentic system as a hybrid system combining various components into each other. And if we think of how an agentic system works, we also refer to the context is king, right? But let me tell you what, the context is not memory. The context is part of the whole decision environment. And therefore, the inputs which are basically influencing our agentic behaviors is first off the system prompt or the instructions, the retrieved documents from a RAG approach or something else, the conversation history. So it matters a lot when you have a pretty solid conversation history already going back and forth between the agent and the user compared to a clean new conversation when it comes to context. The set of tools which are available to the agent and therefore which are then surfaced to the end user, the user's intent, the reasoning of the specified large language model, and organizational policies, and furthermore, memory and prior interactions. So the context basically is part of the whole decision environment. The context, let's say, infuses some certain inputs into the reasoning approach, the tool choice. Therefore, a new context might be set up, and therefore a new reasoning chain might start off. And so you gotta think of the context not only as something which is part of the memory layer, but more part of deciding where the whole conversation goes. And that is why prompt engineering is evolving into context engineering, basically, and why debugging agentic systems feels somehow fundamentally different compared to classical software engineering. So we're not only debugging the code paths when building agents, we're debugging probabilistic behavior emerging from a changing context environment, basically. And therefore, different systems, different system behaviors require us to apply different testing strategies. So once we recognize that different parts of the system behave differently, our testing strategy has to evolve as well. The answer is not traditional testing no longer matters, quite the opposite, basically, but that deterministic components still benefit enormously from unit tests, integration tests, or what have you. But probabilistic components require additional evaluation strategies because exact string matching or string equality often becomes meaningless. Two different outputs may both be acceptable, even if they're not the exact same output. A technically correct output might still represent poor behavior, for instance. So we move towards behavioral evaluation, scenario testing, semantic similarity, or even rubric-based scoring. So we should not abandon deterministic testing where determinism still exists. But we also should not force exact output testing onto probabilistic systems. And therefore, the testing model must follow up the behavioral model of the subsystem we're validating. In our cases, most often, these are agents, right? And so we're not replacing software testing. We're basically expanding it. Different components require different testing styles. For instance, the API connectors we're using in our agents, they might require unit testing still. Whereas prompt interpretation requires us to apply behavioral evals, or tool selection requires us to apply a scenario testing style, for instance. So the hardest problem is not automating those test scenarios, is defining what is good. In classical software engineering, correctness is often binary. So the expected result either matches the exact same result or it does not. But generative systems, they somehow fundamentally change this because multiple answers may be acceptable or partially acceptable, and one may be concise but incomplete. Another may be detailed but verbose. Another may be creative but less grounded. So the challenge is no longer, did the system execute correctly? It becomes more something like, did the system behave well enough for this context? So that sounds subtle, but it's a massive shift because evaluation is no longer purely technical in most terms. And evals encode human expectations. So what does the organization consider acceptable or professional or safe enough or concise enough? And these are not purely engineering questions anymore. They become more of a governance, operational, or even business-wide questions. So this is why artificial intelligence evals become significantly more difficult than classic software testing, if you will, because those generative systems, those agents we develop, their expected output might not always be the actual output. So unit testing cannot be enforced on each and every component of an agentic system. And therefore, evaluation becomes more of a risk management discipline. The goal is not to be 100% certain. The goal is to accept the risks. And this is where the weather metaphor from before becomes especially powerful, right? So weather forecasting is not about eliminating uncertainty. It's about managing risk appropriately. A small chance of rain leads to me carrying an umbrella like today. A thunderstorm warning changes event planning. A hurricane forecast changes evacuation strategies. So therefore, the response scales with risk. And enterprise AI systems increasingly work the same way. So not every failure has the same consequence. A funny internal chatbot can tolerate significantly more uncertainty than like financial guidance agents or healthcare recommendations or even autonomous systems. So the question should no longer be, can this system ever fail? Because that's somehow unrealistic. The more important question becomes, what happens when it fails? That shifts the conversation from impossible perfection towards responsible uncertainty management. And suddenly, many classical governance concepts become relevant again. Risk management, escalation paths, human oversight, operational boundaries, and many more. So AI governance is ultimately uncertainty management. And evaluating agents starts to resemble onboarding employees. To be careful, I'm not saying AI systems are human. That's not what I want to express. But the operational patterns increasingly resemble how organizations already manage knowledge workers. When onboarding a new employee, we do not simply hand over a 400-page spec and expect perfect behavior of that new employee. Instead, we provide context, we provide examples, we provide policy, we even provide supervision in certain circumstances, and most importantly, we provide feedback and bounded autonomy. So trust develops gradually, and we observe behavior across many situations. We evaluate consistency, judgment, escalation behavior, reliability, and that's increasingly similar to how we evaluate agentic systems, not through a single exact output test, but through repeated observation across scenarios. And this is why evil data sets, scenario coverage, trace analysis become so important for those agentic systems. We're not longer validating only the static outputs. We are validating behavioral patterns over time. That's quite important when thinking of evaluating agentic systems. Like I said, testing agentic systems means evaluating over time. And one of the most important insights from modern AI evaluation practice is that evaluation is not a final quality assurance phase. It becomes part of the whole development lifecycle itself. So teams working seriously with agentic systems spend an enormous amount of time on error analysis, reviewing traces, inspecting failures, refining evaluation datasets, and also understanding behavioral drift. And this is very different from classical software testing. Many failures in agentic systems are not binary. They are contextual, behavioral, and emergent. And importantly, production itself becomes part of the evaluation environment. User behavior changes, context changes, model updates happen quite often these days, actually, and tool ecosystems evolve. And so evaluation becomes continuous. There's no point in time, like in classical software engineering, where you would say, now is the perfect time to test or now is the perfect time to evaluate. evaluation should happen continuously. Reliability no longer comes from controlling every possible execution path, but reliability comes from continuously observing the behavior, constraining operational boundaries, monitoring anomalies, and iteratively improving the system over time. And if you pass 100% of your evals, you may not be challenging the system enough. So if each and every evaluation run scores with 100%, maybe you should think about if you are testing your agent the right way. And so let's take a look at evaluating agents within Copilot Studio these days. So what I have in here is my Copilot Studio environment. And this is a pretty basic agent I have set up. The agent is called Clarity Canvas. And the Clarity Canvas agent is our agent when it is on us in our company to clarify the customer's intent, basically. So we use that agent quite often. And this agent basically just consists of a set of instructions. And within those instructions, we quite detailed tell the agent what it should do, right? So it should come up with a status quo. Who is the agent? Who is the customer? Sorry. What do we know about the customer? What do we know about their current situation? And what role and perspective does the person we're talking to bring in? Then we want to analyze the current situation, the problems, the obstacles, the future situation, so the goals and the real goals, how we call them. And we also give him a bunch of output information, how the agent should structure the output. And like you could imagine from that, this agent basically lives off the context we add to the conversation. So if I do not specify who the customer is in the status quo and what do we already know about him and what role and perspective we talk to, this agent won't help us a lot because the whole context basically is missing. And what we have done is we have created a evaluation test set, or basically we've created two evaluation test sets. One has 25 test cases and the other one has 100 test cases, like you see in here. The 100 test case one, this has been automatically created by Copilot Studio. So if you create a new test set, you can generate sample questions using Copilot Studio. And those sample questions, they are based off the instructions, basically. So we have done that. We have 100 test cases in here. And like you can see in here, the questions are missing one thing in most cases. And that one thing is the context. So if we just ask that question, and I'll just copy that question over and open up the test pane and ask that exact same question. Can you analyze these customers' emails using the Clarity tool? And if I don't add anything else, it will tell me, certainly, but please provide the customer email. And that's exactly the context the agent in that case is missing. So if I would run that test set, which I can do, but I've done that already. If I run that test set, we see we get a score of 95%, of a passing score of 95%. And if I, for instance, pick one question in there what are the typical goals for customers in the public sector, it will generate an answer which might be beneficial to me. But in most cases, if I do not pass in the context, the answer I retrieve is not the answer which is helpful to me. So what I want to tell you with that is be aware that even if your test passes, it might not be beneficial for the end user on the long run if you do not think about adding context to set evaluation test sets. And so what we've done is we have created another test set with just 25 questions. But in those 25 questions, like you see in here, we pass in a context for each and every question. So an example question would be analyzed with the Clarity tool. Here's the context, email from CityCom's lead, yada, yada, yada. If I now take that exact same question, open up a new conversation in here and ask the same agent, almost the same question, but with a bit more context, I retrieve what I want the agent to come up with. I retrieve the status quo, I retrieve the current situation, the obstacles, I retrieve the future situation with the goals and real goals, and that is helpful to me. So again, if you are planning on creating testing automation for agents, in that case in Copilot Studio, think about how you define and design your evaluation test sets. Make sure that if your agent is really depending on the user's context or the conversation history, to add those bits and pieces into your test set questions as well. And also make sure that when defining your test set, to pick and choose the correct test method. And in my case, I've not only picked one, I've picked two test methods, which is general quality. General quality means the answer meets quality standards such as relevance and completeness. But I also picked compare meaning. So this basically means that answers have the same meaning as the expected response, even if they're worded differently. So then I can gain insights even if a user comes up with a question which is completely different phrased, if the answer will still be relevant to that specific user. And if you do so, you will have at least more insights in where your agent still lacks certain either parts within the instructions, or if the agent is not using the correct set of tools, or if the agent is not using the correct grounding information from its knowledge sources. So that's basically the default features within Copilot Studio when it comes to agent evaluation. But where does the built-in evaluation basically stops? So Copilot Studio evals, they get you started, but they don't get you to a complete release pipeline. As of now, Copilot Studio evals can run and visualize those eval test sets against an agent in Copilot Studio. They have built-in metrics for groundedness, fluency, similarity, and they offer you a quick feedback loop while you are authoring your agent. And like I said before, evaluation should happen continuously, not at a specific point in time. But Copilot Studio evals, basically, they just live in the cloud agent. They don't live in source control. There's no gate in continuous integration before deployment where it says all of the evals have to be run and a certain passing score has to be reached before the agent can be published. And also, it's hard to branch, review, or even share those test cases in Copilot Studio as of now. And so therefore, you also should know about the anatomy of a Copilot Studio agent to understand how you could predominantly test your agent in Copilot Studio. So you should know that there's a concept which is called topics. Topics are basically the dialogues within your agent, your conversational flows triggered by the end user's intent. Then there's tools and even other agents. Tools could be connector calls, agent flows, MCP servers, or other agents which are called from your agent. Then there's knowledge, living in SharePoint, Dataverse, websites, from file uploads, or even your line of business apps. And then there's variables, which could be filled using slot filling, could be used for state management, could come from environmental configuration. And if you understand all of those building blocks, you also understand what could possibly go wrong. So wrong topics could be triggered for an ambiguous user input, for instance. Slot extraction misses or even hallucinates a value when setting a variable. Tool fires with the wrong parameters or even the wrong tools get selected. Knowledge retrieval returns stale or even irrelevant chunks of knowledge, and generative answers drifts in tone or factuality. Those are just examples of things which might go wrong. And so each of those building blocks has its own failure modes and therefore requires its own testing strategy. So the challenge really is that Copilot Studio agents, or basically every other agent type as well, they are non-deterministic by nature, and one prompt can change or one prompt change basically could break a lot of test cases. Manual regression testing doesn't really scale across environments in Copilot Studio or even languages. So without automated testing, every release of your Copilot Studio agent becomes a leap of faith. And that's a pretty big challenge these days. And so unit tests, they assume deterministic outputs. Agents, they're not deterministic, as we already know. Exact string assertions fail on minor phrasing changes, which are still correct or not. End-to-end UI tests might be what you're looking after, but they're really slow and also expensive at scale. And coverage is pretty hard to define when the input space is everything a user could possibly say. And therefore, we should design our agents for testability. And what do I mean by that? Split your agents into small single-purpose topics. Define success criteria per topic, either intent match or slot extraction or action invoked, whatever. Keep the tools or the connectors you're using within your agent behind an abstraction so they can actually be mocked, because if you could mock something, you will have an easier time while testing. And also define the right validation criteria. So for instance, for intent match, you would look after, was the right topic triggered at the right time? For slot accuracy, you basically think of, did we extract the right entities and the right values? For action correctness, we should think of, was the right connector called or was the right tool called with the right inputs, with the right parameters? Response quality could be something along the semantic similarity to the expected answer, such as the blur score, or you could even use another large language model as the judge. And for tone of safety, you could ask yourself, does the response stay on brand within the policy we applied? And for latency and cost, we could ask, is the response time and the token usage within budget? And like you see in here, these are a lot of things to think about when building an enterprise-ready agent. And some of those things are not even yet covered in Copilot Studio, but even if they are, we should, or in most cases, we seek of a process which can be automated with ease and can also be included in an ALM process, right? And certainly, the evaluation feature in Copilot Studio lacks certain possibilities when thinking of ALM at the moment. And therefore, what we have created is a tool called CALT, stands for Copilot Agent Linting Tool. And that tool basically gives us the flexibility of evaluating an agent wherever you basically want to evaluate it. So what I have here is, I have another agent, which is the default website Q&A agent deployed in Copilot Studio. And that agent basically should respond with information it finds within the set of knowledge sources. In my case, there's one website attached as a knowledge source, which is the Microsoft website and nothing more. And this agent is pretty blank at the moment. So there are no evaluation test sets created in that specific agent. The instructions are pretty basic, consisting of 2 sentences. So there might be things we could improve within our agent. And obviously, we could now go ahead and do the same thing as before, creating our evaluation test sets right within Copilot Studio. But as said, this may not be the full-fledged ALM-ready process to do so. So what we have come up with is a CLI tool for linting and evaluating a Copilot Studio agent and even other agent types like Microsoft 365 Copilot declarative agents. So I will open up a new CLI console in here, and I'm already logged in to my Cult CLI. So first off, what I can do is from that specific CLI interface, and I'll make that a bit taller so you can read that properly. I can execute a command called cult fetch list, and I just wanna see the list of Copilot Studio agents in my tenant. And like we see in here, we get back a lot of agents which reside in my Copilot Studio tenant in different environments. So the website Q&A agent is in a specific environment, and there are other environments. And now we can actually scan our agent by using another comment. And the only thing we need is to pass in the agent ID to make sure that our CLI tool is able to scan the remotely hosted agent. And that scan basically gives us back a certain information. First off, we see that the instruction quality is not the best. There's no clear purpose or even an objective section found in our instructions. And if I go back to the instructions, we'll see that's true, because those are our instructions. Next thing, we see there's no markdown structure found within our instructions. There's no step-by-step workflow defined in our instructions. Few or even no actionable verbs are found in the instructions. There are no examples, no error handling, no output format rules, and the instructions may be hard to pass. So those are things which are somewhat obvious if you read them, but those are things we do not see within Copilot Studio directly. And therefore, we have built this tool to raise awareness that even though your test cases might be passing, there are certain things in certain components, most commonly in the instructions, which could be improved. And also, what we retrieve is certain security information. So ranging from the OWASP large language model top 10 security measurements, we see that there are no prompt injection guardrails detected in the instructions, no prompt leakage guardrail found, and no uncertainty handling guidance found within our instructions. So those are things which we could work on. If we want to have even more information, we could execute another comment, which is linting. So we see at a glance our suggestions. Which things should we tackle immediately? Add an objective section, add a workflow section, add examples, and add error handling. Those are the things we should do immediately. And the cool thing about the cult CLI is, with a simple --fix parameter, we could even use the tool to apply those fixes automatically, which we won't do for the sake of the demo now. What this tool can also do for us is we can even fetch certain configuration objects and bring them onto our disk. So what I've done is I've executed this fetch command, and this fetch command basically extracted the instructions for us so we can have that instruction set checked into our source control, for instance. So we have version controlling on our instructions by using that tool. And those are basically the instructions from our Copilot Studio agent, along with a set of metadata, display name, last modified date time, and whatnot. So we can even export the heart and soul of our Copilot Studio agents, which is the instructions, and apply them into our source control process. And what we also, in terms of automating the testing routines, is we can come up with a set of evals locally. So this is my test case set with a bunch of questions, a bunch of expected responses, and the testing method we want to apply. And obviously, those test cases, they are generated using GitHub Copilot in my case, but you can come up with anything else as well. And so I can now come up with my test cases within a YAML file locally on my machine, store that that test case set locally. And then what I can do is I can use the CLI again to push those test cases onto my remotely hosted Copilot Studio agent. So I run cult eval push, refer to the YAML file where all of my test cases are stored. And obviously, I need to mention the bot ID and the environment ID. And as this feature is using a non-officially documented Copilot Studio API, this feature is experimental. So be aware that this might not be fully supported by Microsoft, but still it shows you how to create test evaluation sets locally, check them into your source control system, and either from a local machine or from a GitHub workflow or Azure DevOps workflow, push those evals onto Copilot Studio. And if we now switch back to our agent in Copilot Studio and go to the evaluation tab, we see that there is a new test set created with 10 test cases. And those are the test cases from our YAML file. And obviously, we can now go ahead within Copilot Studio and click the Run button. But maybe you also want to automate that. So we go back to our CLI instance and execute cult eval run to actually run the previously created evaluation test set. And this takes a couple of seconds to run our evals. But the good news is it does not only run the evals, it will also give you the run outputs right where you're running it. So you don't need to switch back to Copilot Studio to drill into the results of your evaluation run. This will be presented right from your, for instance, terminal instance, like we'll see in a minute or two. If we go back to Copilot Studio and refresh that, we'll see that the evaluation has been kicked off already and is running. Yep, it's still running. So we'll see that we can automate the whole evaluation process from creating the evals from your favorite CLI or CI/CD pipeline up to running it, and then again also monitoring those evaluation test sets right from where you are, which then perfectly fits into your application lifecycle management workflow, if you will. And then it's really enterprise ready to come up with evaluation test sets, share those evaluation test sets with different kind of stakeholders, even though you do not need to give them permissions on the Copilot Studio agent itself. Run it wherever you want to run it, and see it's now finished. So if we go back to our terminal interface, we see the results in here, we see the passing score in here, and now if the passing score is 10 out of 10, we could then go to the next stage and, for instance, publish our agent or deploy our agent or make the newest version of our agent available to the end users. Whereas if it doesn't pass all the test sets, we might want to stop the publish or deployment process at that very moment and let the agent authors know that there are breaking changes in there. And if that's cool for you, but you want to have it more officially supported. There is the Copilot Studio Kit, which is built by the PowerCat team, which also offers you evaluation metrics and automated testing routines in there. So be sure to check out the Copilot Studio Kit if you want to have more enterprise-grade evaluation testing in Copilot Studio added. And so, as we are already coming to the end of today's webinar, here are certain helpful resources for you. If you want to try out Cult, please give it a go. If you have feedback, let us know in GitHub. Create a new issue in there. If there's something missing, create a new pull request in there. If you want to test out the Copilot Studio Kit, here's the link to it. And if you want to hear about my thoughts or Tommy's thoughts, who is not here yet today, here are our blog URLs.
Perfect.
And with that,
do
we have any questions?
Thank you, Stephen, for a great presentation demos. So now we'll get into question and answers portion of the session. If you would like to ask a question, please feel free to type in the chat box now. And first question is, does the CLI tool provide a complementary KB set?
No, you would need to come up with your own test sets.
Okay, next question is, what are the biggest architectural mistakes teams make when designing Copilot agents that later become difficult to test?
Sorry, what again?
Sorry, what are the biggest architectural mistakes teams make when designing Copilot agents that later become difficult to test?
Oh, that's a tough one. It basically depends on the agent's use cases, right? So I've seen agents consisting of a single topic with a lot of branches in that topic, which is pretty hard to debug on the go, which might be the right architectural option in one case, but might be the complete wrong architectural option in another case. So this really depends on the use case. There's no right or wrong by default. But I would say, like I said earlier, split all of those building blocks into small manageable chunks maybe is a good option to go.
Perfect. The next question is, does Copilot Studio support tool testing?
Dual testing?
Tool testing, yeah.
Tool testing.
Tool
yeah.
testing, yeah.
Yeah, it does.
Perfect. And the next question there is, how do governance and approval processes scale as companies start building more agents?
They only scale if you have, from an organizational point of view, implemented them. Because if you just rely on the goodwill of your agent authors, you might be disappointed.
Perfect. The next question is there, what metrics should teams monitor after deployment to know if an agent is performing properly?
I would say whatever type of measurement which makes sense to your agent use case. Obviously, I would say the system quality, groundedness, if you are relying on grounding information, tool selection, if you're relying on tools and actions. Those are the ones I would go for.
Perfect. That looks like all the questions. So on behalf of the ESPC community, we'd like to extend a huge thank you to you again, Stephen, for taking time out today to carry this webinar. Really appreciate it.
Thank you. See you.
See you guys.
Bye.